So a fair while ago I sat down with an idea in my head, an idea for a math. The general thought was that if I were to take a y equals x line, split it into segments, and then move the segments up or down such that they basically replace each other on the vertical axis, then the function would maintain a sort of invertible one-to-one correspondence. It would still have exactly one y value for every x, and vice versa. More to the point, if I segmented it again and moved the bits again, this property would stay intact through any amount of iterations. Being the graph man I am, I then executed it in Desmos. I designed a function based on absolute values and signs that looks like this. Let's break that down. We all know the sine function, a wave with a cycle of 2 pi that occupies alternating positive and negative values. If we multiply the input by pi, we can shorten it such that between 0 and 1 it's positive, then 1 to 2 it's negative, then positive, then negative, and so on with the zeros lining up with the integers. Since the absolute value function for real numbers can be thought of as multiplying negative inputs by -1, I can then just do this little division trick to make any positive values become 1 and any negative values -1. So that's my f of x, and on its own it would guarantee me one iteration of what I had originally planned. Neat, I guess, but what I really wanted was any number of iterations. The iteration setup I used looked like this, with I being the number of iterations I wanted to do. I figured if I just added on more smaller versions of the function, that would satisfy an iteration, and sure enough, it works. I don't know what exactly I had envisioned, but I guess it was more glamorous than this. If I wanted the slope of a negative x graph chopped up and moved along an x-line, I would have just written this. Where's the drama? It was at this point that I decided to replace the sine in the base function with a cosine, and the graph became this. Oh boy, there's the drama. I switched back to sine right about then, adding the variable s to shift the base function to any point within its cycle. Given what sine and cosine are, setting I to 0.25 replicates the cosine situation. Observing this edited version turned up some things. Doing individual iterations, you can see that the original property is maintained, but that ceases to be interesting when you consider that at high numbers of iterations, the thing seems to be taking on fractal properties. Taking out the diagonal line and just watching the bit between 0 and 1 iterate is how I'm wrapping my head around this thing. The first iteration segments it out, and those segments go up and down as planned. These segments then split, but the directions their pieces travel is varied between the pieces. One has its right going up, the other down. Continuing the pattern, the segments split and then travel, alternating from piece to piece until it's all scattered. Repeating the same kind of segmentation and travel is what causes the fractal appearance, as each region of division is just a smaller version of the larger division that's already occurred. I recognize the whole function is really simple and inconsequential, but I've got one last thing to say on it. If this becomes a thing, can we call it the dust with the must